everyone, to all the viewers, ma'am. So this report uh, talks about quantum computing and its effects, as well as the different aspects and key principles that affects it. So first, what is quantum computing? As you can read here. Basically, try to imagine solving a puzzle with billions of pieces. So if you're going to do it manually or using a classical computer, step by step, it will be too hard or it would be too time consuming. So by using quantum computer, we can look at many possibilities at once thanks to the strange rules of quantum mechanics. This ability could revolutionize fields like medicine, finance, and artificial intelligence by solving problems that are practically impossible by today's machines. So as you can see here, it's an emergence field of computer science and engineering that harnesses unique qualities. So as you can see here, there are different practical applications for quantum computing. So there are modeling, identifying patterns, etc., etc. So here are the four key principles of quantum mechanics. So first is superposition. In classical computing, a bit is either a one or zero, true and false, etc. But a quantum bit, or they call it qubit, can be both at the same time until we measure it. So that will leave us a lot of possibilities in measurements, and so that we could explore it efficiently. Next would be entanglement. So when two qubits are entangled, they become linked in such a way that the states of one another instantly affects, no matter how far apart they are. So next would be decoherence. Quantum states are extremely fragile. When qubits interact with their environment, they lose their quantum behavior and collapse into classical states. And lastly, interference. Quantum states can overlap, and when they do, they can either reinforce each other or cancel out. So that's the simplified principle of quantum mechanics. So how do quantum computers works? So as we said earlier, uses qubits instead of bits. So while quantum computers do not use binary code, qubits process information differently from classical computers. So imagine that, let's say for example, a computer can, let's say for example, crack a password, 8-digit password, and let's say for example 1 year. Quantum computer can do it in a few seconds. So it actually has a bright side and then a downside, since it also empowers different hackers, etc., for easy cracking or easy hacking that would influence us as well. But here are the benefits. So with its unparalleled speed, efficiency, and advanced security, so it's going to have a groundbreaking benefit. So it utilizes qubits, advanced algorithms, enables more efficient parallel processing, etc., etc., etc. So why is quantum computing important? So it can solve problems that classical computers struggle with, such as optimization, simulation, and advanced data analysis. Actually, it would have a great impact as well on artificial intelligence, since artificial intelligence is bound by what we can accomplish today with our uh, computers. Having to have the power of quantum computers would have an immense impact on artificial intelligence.
What are qubits? A qubit is a fundamental unit of quantum information analogous to a classical bit, but it can exist in a superposition of 0 and 1 states simultaneously. A qubit or quantum bit is a basic unit of information in quantum computing. Unlike a classical bit that can only be 0 or 1, a qubit can be 0, 1, or both at the same time through a property called quantum superposition. Another property, called the quantum entanglement, allows qubit to be linked so that the state of one can easily affect another. So let's tackle the different types of quantum qubit. First, the superconducting qubit. It is widely used by companies like IBM and Google. They operate in extremely low temperature and are very fast, but they require complex cooling system and they are sensitive to noise. Second is a trap ion qubit. Use charged atom controlled by laser and electromagnetic field. They operate slower but are very stable and accurate, making them useful for research. Third is the topological qubit. It is still in experimental but promising. They store information in the topological structure of particles, making them potentially more resistant to errors and environmental noise. Fourth, it is a photonic qubit. It uses photons or the particle supply to carry quantum information. They can work at room temperature and are useful for quantum communication and networking. Fifth is the quantum dots. So quantum dots qubits trap single electrons in tiny semiconductor structures. They are very small and compatible with modern chip manufacturing, making them promising for scalable quantum computers. Advantages of qubit. Because of superposition and entanglement, quantum computers can solve certain complex problems much faster than classical computers, such as simulations, optimization, and cryptography. Disadvantages. Qubits are very sensitive to noise, require special environment, and are expensive to maintain. In conclusion, qubits are the foundation of quantum computing. Different types offer different strengths. Some are faster, more stable, or better for communication. As technology improves, qubits may greatly transform the future of computing.